Okay, in this introduction we're just going to look at the two main types of wave, describe the properties of these waves, and make links between wave frequency, the wavelength, and the speed that these waves travel. Okay, so first of all, to look at the two types of waves you're expected to know about, we have transverse waves and longitudinal waves. The first thing you should notice is that in both of these waves, the particles aren't actually being moved from one place to another. The particles are just oscillating, okay? So waves, they don't move particles, they transfer energy, all right? The particles just oscillate. So in transverse waves, the particles oscillate perpendicular to the direction of transfer of energy. So they oscillate up and down. If you think about the slinky demo we used in lessons, okay? And that's probably more the traditional wave you've seen in the past. We also have the longitudinal wave. Here the particles oscillate parallel to that direction of energy transfer, okay, and you can see this through compressions, which is where the particles are close together, and rarefactions where they're further apart, okay, and this is where they fit into the spec, okay, so you're supposed to know the direction that the particles oscillate compared to the direction of energy transfer. Just looking at this again to reiterate that the particles aren't transferred from one end of the wave to the other. If you pick a particle out in this small animation, you should notice that it doesn't actually move from one end to the other, it just oscillates backwards and forwards. Okay, this is obviously a longitudinal wave. As you can see, compressions and rarefactions. So wave properties then. There are three main wave properties you're expected to know. The first two are wavelength and amplitude. Okay, the wavelength is just the distance between two identical points on a wave. Easiest way to do this is between two peaks or two troughs. The second, the amplitude, is the maximum displacement from the line of equilibrium. Alright, so you can think about this as a bit easier, I suppose, as the height of one of the peaks or the depth of one of the troughs. The third and final property you're expected to know about is frequency. Okay, so now it's very hard to draw frequency on a wave, so instead we draw the time period. So if you imagine that the axis that this wave is shown on, along here, is now time instead of distance. One period is the time it takes for one wave to occur. Okay, and the frequency, which we measure in hertz, is 1 divided by this time period being measured in seconds. Okay, so for example, if we had a wave with a time period of 2 seconds, the frequency would be 1 divided by 2, that would be half a wave every second, okay, or half a hertz.